The difference is here actually required to be defined between the transaction isolations levels, the T-SQL transactions isolations levels, and the transactions properties. Properties we saw actually the asset, the atomicity, the consistency, the isolation, and the durability. And those are actually some attributes, properties, aspects that the system has to guarantee on top of the transaction in order to either secure the transaction from being intercepted or to make an assurance, to present an assurance that the data manipulated is guaranteed, no more, no less. The transaction isolation level, still we are talking about security perspectives or views. Yeah, the transaction isolation level, it's a mode of execution. We're going to allow the addition or not. We are going to admit the modification or not. Things like that. So the isolations levels, they are execution modes. Yet the properties, they are attributes how to secure and guarantee the manipulated data. Those are two different views. They are not in the same channel to compare, but they are complementary because they are dealing with the transaction, the T-SQL transactions. Simply. So we continue from where we stopped. We reached to define the transaction modes, the four of them, and we saw an example of each of them. Actually, the four of them, the four transaction modes, they are the modes via which we can execute a transaction, or a transaction might be executed within a program, starting with the explicit transactions. Then there is no order, actually. There is no first, second, third. No. It's not like that. There are modes, and that's it. Based on the project, based on the task to do, the mode would be actually imposed. But there is no priority to choose the first or the second. No, it's not a matter of primordial selection. The auto-commit transactions, the list or the group of the auto-committed transactions, they are transactions with one query each. We have a transaction with one select. We have a transaction with one insert, one just query, SQL query. So those are auto-committed transactions. So the system will auto-commit them straightforward. Whether they are doing an insert or an update or an alter, the system will auto-commit them, automatically pass the commit command to the environment. Environment means the SQL server. Auto-commit transaction mode. What it concerns the the implicit and the explicit transaction modes, those are two transaction modes where we can see the beginning of a transaction clearly, and we can see the termination of the transaction clearly also. They are similar almost, and we can see the indication of the commitment, either to commit or to roll back the transaction. This or that. So both of them, they are have an indicator. Yet what it concerns the explicit, actually, it is here a scenario where we can see the nested transactions, where we can see a second transaction immediately starting right after the end of first transaction. So here it is a little bit actually more, let's say, obscure than the implicit in terms of when to start a transaction. But both of them, they are indicating the start and end, yes, and somehow. Yes, and they are indicating, yes, the end of a transaction means there is a commitment, either the commit or the rollback. The fourth transaction mode, the batch scoped transaction, is a scenario in which we can see new technology put in to a question. This specific type of this specific type of transaction modes, mainly it is dedicated to the .NET solutions. It is clearly manipulated with the .NET technology. The definition does not specify that it is a .NET or not, but in real plain, it is implemented with the .NET solutions only. Since it is defined by the SQL Server and the Microsoft specifically, it is so to be said that it is a .NET related solution only. The batch scoped transaction mode. The batch scoped transaction mode. This batch scoped transaction mode is a mode via which we can see the birth of the mass technology, mass multiple active result sets, queries or transactions or programs, let's say, multiple active result sets in plural, where we can see more than one command acting in just an environment, and all of them, they are dealing with the same transaction. And all of them, they have to be actually committed or rolled back together. Multiple active result sets. Be specifically implemented within a .NET because it is clearly discussing the example that the .NET defines. We'll see an example just right after. Just one note is that when implementing a transaction based on the batch scope transaction mode, the definition of save points across the program cannot be integrated with the transaction in question. What does it mean? There is a technology said nominated save points during when writing actually a SQL Server based project, and when specifically when writing T-SQL solutions. Those save points, they cannot be integrated within a mass based transaction. Within a mass, what does mean mass? Multiple active result sets transaction. Those save points, they cannot be actually integrated or, let's say, defined. They cannot be utilized. Why? Because we see the example right after. We cannot roll back a transaction that it is committing both commands or two or more commands at the same time. So either to commit the transaction with this content or to roll back the transaction with this content. Okay. The example you see in front of us now is it's a transaction that it is defined a list of queries which they are not mass based. What does it mean? Means they are not related to a transaction or an environment where fully it has to be committed or fully it has to be rolled back. Thus we can see in between here there is a save point defined. This is a keyword. This is not a keyword. This is a word defined. Yes, user defined word save point. I can write sp save point. I can. It's any name that we can use it later on. But save run or save a transaction is a queue that defines this time-based point within the project. The queries we have actually, before that we have a list of queries. After that we have still queries. And in between we are going to roll back, cancel means we're going to roll back up to where we define the save point. And after we continue our transaction with other commands, then after we commit, the commitment here is for all what preceded. This block has been rolled back, and this block has been admitted so far. Great. So here, because of the non-aspect of being mass, we are able to define and use the save points. Let's compare this transaction with the next example, what we're going to see now. Here we are defining connectivity to a server. We are having a command number 1. The command actually is going to have an indicator. Actually, it will be dealing with the server based on this connection. Yeah, and it has a query to do command, the content of the command. Great. Then a second command that also is going to be linked to the same server, the same data source, and it has a content, a command to do, to execute. Those two commands, cmd1 and cmd2, they are going to be linked to a transaction called here. Actually, it's a .NET transaction, SQL transaction. cmd1 transaction is tran, and cmd2 transaction is also tran. Simple. So both of the commands, they are linked to the same transaction. They are under the same transaction. Okay, here, continue. We are going to execute a block from here to here to here. In between those two curly braces, this curly brace and this curly brace. This is the transaction body from here to here. Why from here to here? Because we are using the exception handling try to see if it would be actually executed without any runtime errors or not. So the transaction would be executing the query, whatever. This is the query number 1, number 2, whatever. If it gets executed or not, we'll check later. But both of them, they are going to be executed. Okay, once executed, okay. Otherwise, if there is any exception, means any runtime error that happens in this block only, the catch block would be launched. Here it is. Means if there is any runtime exceptions, whatever the exception is, means errors during the runtime, this block would be executed. Only unless any error happens during the runtime, this block will not be executed. And the commitment is going to be applied on the tran, and the tran has the two commands linked to. So we cannot commit command 1 and neglect command 2, or we cannot roll back command 1 and commit command 2. No, both of them either committed or rolled back, because the commitment is on the transaction, not the command. So thus here we cannot specify the save points. It's not the place to indicate the save point or to use a save point. This is a mass transaction. Here is an example of a mass transaction. Mass transaction, multiple active. There is multiple here. We can see that through the two commands. Each it has its own commands, its own queries to do. Any questions, please?
No question.
No question, Mr.
Yeah, this is great. This is great. So actually, this is what it concerns the transaction modes. Transaction, when we say transaction, mainly we talk about this, the T-SQL transactions the bodies that we are using, the definition of the new technology to deal with the SQL queries, specifically on top of the SQL Server environment, transaction modes. We pass to a new, let's say, feature or technology, which is the isolation level. Isolation level. Here we can define a new aspects and new perspectives to secure the execution of transactions and to guarantee information assurance here, to guarantee that the queries are being valid and not falsified. The contents are being trusted somehow. The isolation levels. We have more than one isolation level. Actually, we can see that in our table. It's available in our book. You have to read about them all. Just briefly here, before we do anything, the isolation levels, they are sorts of, literally said, to isolate a transaction within specific circumstances. What does it mean? Let's take an example and I'll come back. Yes, take an example and I'll come back. We said that the isolation is to isolate a transaction from the external environment within a specific circumstances. Isolate means isolate. It would not be actually seen by the external environment, or it would not be interfered or let's say any injection in between, interception, nothing. Isolated, full stop. That's what we mean by isolation level. Yet this isolation is not standard for all, because the isolation can lead to fully isolate the transaction in question. Means the full program will stop until this transaction in question gets finished. Then after the others, or the program will resume to continue. Okay, what does it mean here? Here that the content of the transaction in question, when we talk about a complete isolation, will be executed fully, and at the end of after committing or rolling back the transaction, the program will continue, will resume and continue its process. The program, not the transaction. So this means this is a level of isolation. This is a level. A full isolation is a level. The example I discussed here is the serializable deadlock, actually, the serializable transaction. And this is, the isolation level serializable. As per literally said also, we are going to serialize the execution of the transactions in plural within the program one by one. The transaction 1 has to finish fully in order to start transaction 2. Then transaction 2 has to start and finish fully in order to start transaction 3. Then transaction 3 has to get finished fully in order to start transaction 4, and so on. This is the serializable deadlock, or the serializable transaction isolation level. This way, we can understand that there are different perspectives and different approaches how to isolate the transactions. Before we discuss the other modes, the isolation levels, why we talk about isolation definitely actually from the beginning. It's not what are they, but why they are actually given birth, and why they are defined with the SQL Server environment and within these T-SQL solutions. The point is that here actually the isolation is a context of securing a transaction. Let's take the example of the EduWave. How many users are using the EduWave? Thousands and thousands of users, all the students, all levels, all the faculty, all the administrators, thousands of users. And they are using the EduWave at the same time during the registration, for example. This huge request on the same resource during a small period of time can cause system to failure, can lead the system to failure. failure in terms of executing correct queries, displaying full profiles, displaying everything, actually making the appropriate updates, failures in those terms, things like that. So, yes, the system will fail. The computer will fail in serving thousands and thousands and maybe millions of requests, because they are simple requests. A user can make 2, 3, 4 requests per second. This huge number of requests per second can cause the system to fall into an error, displaying erroneous results, making erroneous computation, erroneous or even missing computation. So thus, it is a must to isolate the transactions from each other, but with different perspectives. Each transaction with its circumstances, with its scenario. The serializable isolation level literally said it would serialize the transactions available in the project or in the environment to be executed one after the other. Once one starts, all the others, they are locked. Thus we talk about deadlock. It causes a deadlock to all the other transactions. Deadlock means they have to be blocked, not executed. There is no parallel execution here. We are talking about serializable transaction, serializable isolation level. Another example, the snapshot isolation level. Here there is an image of all the database objects, and this image actually it would be utilized for different purposes. The point is that there is no lock on the transaction in question when dealing with the snapshots. Here we come back to the story of the change script and the way how the system will make updates from the offline database to the online database without break time, without down time. Why? Because the snapshot will not lock the other transactions. It will not stop the other transactions to continue, to finish. Then it would be executed, the snapshot. No, everything will continue running as usual, and the updates would be taking place also at the same time, live. So here the isolation levels, they are not the same. They are not with the same views or perspectives. They are based on the need, because when we use the snapshot, we are making updates from an offline to an online, or from a local DB to an online, which is not the case when we deal with the serializable isolation level. Serializable isolation level, it's a one of an update, maybe, yes, or an addition, but with complete isolation. Because the isolation here is the updates or the work will be done on more than one entity at the same time. And those entities, they have to be updated before they get executed by other transactions. I will stop at this level. Actually, I will stop at this level, waiting for the others in order not to trespass them. Next class, we'll finish this chapter number 4. You're in semester. We'll cover 2, 3, and 4. Chapter 2, chapter 3, and chapter 4. So I'll give you the recording just right after.